Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hi everyone, I'm Francesco. I'm the founder and technical director of Erlang Solutions. I've been working with Erlang, initially a programming language, which later became an ecosystem of languages, since 1995. And we're here today to talk about the whole theme of problem solving with both technology and technological issues, but also political and managerial issues.
Hi, I'm Robert Virding. I used to work at Ericsson and was one of the initial developers of Erlang together with Joe Armstrong and Mike Williams. This then became the Erlang language and, well, as Francesco mentioned, part of an existing ecosystem.
Can you tell us a little bit more about how you came about, who came up with the idea of inventing a programming language? Was it a particular problem you were trying to solve?
It was a particular problem. We were looking at telecoms applications. And we'd done a number of, we were working in a computer science lab, but we'd done a number of experiments and found that no language we thought really well suited to solving that problem. And that evolved then into looking at how we would like to solve it ourselves, understanding more properties of the problem, and also developing a language that suited attacking these type of problems. We were very lucky to have an external group who came with a lot of feedback, who were very knowledgeable in the systems themselves, what they needed to be done, and they could give feedback on our ideas of what should go in the language and the properties and how you would use these things to try and actually solve the problem.
How was it perceived internally within Ericsson at the time? I mean, there's a Erlang the movie which has kind of leaked its way and made its way out on YouTube.
Yeah.
But what was management's view?
Well, there were a lot of projects internal Ericsson projects going on, trying to develop the new systems and architectures for new systems. So in that sense, we were one of them. And well, like all of them, some people supported us and some people didn't like us, right? But we managed to keep on going. We managed to get the first group who were using Erlang in a commercial product inside, and I think that did very much to ensure that it would keep going. Right?
What year was that? When did they start working on this product?
The product came out in 94. I think they started sometime in 92 to work on the product. But this was the group who had given us all our feedback for it, so they were very into the system and how we intended things to be used and things like this.
And so it came out in 94. I assume that 94, that's when it went into maintenance mode, new features started being developed. How did that influence the language?
The base part of the language was still the same. We'd got that right. Or right of the way you could use that to build whatever you need. But new things had to be added in the language that came along. New requirements came, a few new data types and things like this that were required, or that the people wanted to do that to build their systems more efficiently.
What got Erlang mainstream into Ericsson? I mean, when I joined Ericsson in 95 and then as an intern and permanently in 1996. And in 1996, it was really becoming mainstream and all new projects were using it. What happened between, say, 94 and 96?
There was a large internal project inside Ericsson looking at developing how to develop the architecture for the new system. And that project, it failed. It just didn't work. Their system didn't work. And then they had new products that came along, had to start looking for something else, and they started using our system.
So basically there was a void all of a sudden, a project failed, there was a huge void.
Yeah.
And so, they could either do nothing or bet on something new, which might save their bacon.
Yeah.
Is that?
But there were a number, we weren't the only part in Ericsson trying to develop new things as well. But our system, well, it worked. And there was a product to show that it actually could be used.
So very cool. At the time, there was lots of products which were being started. All of Ericsson's broadband solutions, so ADSL, fiber optics, HFC, so broadband over cable TV networks, the predecessor of WiMAX, GPRS, the XD301 switch, they were all based on Erlang.
Yeah, it was a time of a major change inside Ericsson, what the type of products Ericsson were looking at. Before that, it had been the AXE telephone exchange, which was an extremely successful product, no doubt about that. But then new requirements came, new technology, new ideas, and they just had to get into the system.
It was a whole migration to packet-based switching.
It was
from kind of fixed. You no longer needed a copper wire from one end to the other.
No, that was a major change. It was a major change. It was a major change in the system, and what was required. And I think it's just because of the major rethink in almost everything, that was a time when new ideas could get in.
Two questions of the time before. When Erlang was only available within Ericsson, I mean, all of these projects had 100+ developers. Did Ericsson just go out on the street and find 100 Erlang developers for each project? So I think at the time they had something like 15,000 Erlang developers or something. It was not 15,000, sorry, 1,500 to 2,000 Erlang developers, and and we have today companies complaining, it's so hard to find Erlang or Elixir developers. How did Ericsson do it?
That was basically internal people. So they said, yes, this product is now going to use Erlang, so now they've got people to go out and learn Erlang, so they could work on this as well.
How long did it take them?
That could vary a lot, depending on what they were doing. It could sometimes go very quickly, sometimes take a year or so. Very much depend on the product and the pressure or the push on it to do these types of things.
Because I recall studies from the GPRS project, which has today become the 5G, which unfortunately were never published externally, but internally within Ericsson, they came to the conclusion that a student or a graduate straight out of university was productive within a month of having attended 2 courses and have dabbled and done a bit of self-learning. Someone who'd been working with a particular technology for a long time, it took them about 3 months before they became productive. And these are pretty impressive numbers at the time. Do you recall?
I don't recall directly. I know that we took part. This work was still working in the lab at this time, but we took part in doing training, internal training for Erlang people, or Ericsson people, teaching them Erlang. And there were quite a few. We did quite a lot of that. And I think it very much depends on your background. If you'd work with other systems, you might have become more locked in that technology and might take more time to migrate from it and to rethink, because it was a large rethink for many people. Still is, actually.
What was the first company outside of Ericsson you learned about which was using Erlang? So not university or academics. I know there was a very strong support back then.
So what happened was, in 1998, Erlang became open source, which, if I remember correctly, was Ericsson's first open source software. And a group of us left the lab in 1999 and formed a company called Bluetail. And I think we were the first company outside Ericsson to use Erlang in a product for it as well too. This was in the middle of the IT boom, so it was quite an experience. And then I know you left later to form what is now Erlang Solutions.
Yes. So what got Erlang to be released as open source? Because I mean the whole the Cathedral and the Bazaar paper had just been written. 98. I mean, it was the year the term open source was actually coined. Yeah. So it was something very scary and very novel for higher management.
Yeah, it was. We were very fortunate there. In the group, not inside the lab, but in the group working, spreading Erlang inside Ericsson. There was a woman called Jane Wallerud. She was working with that group, and she was the base of getting the Erlang language open source. She knew how to talk to people and get them to understand that this would actually benefit Ericsson, and it should be much better than having some form of secret internal technology which you didn't want to spread.
But what were the benefits she sold in to management?
You're getting more people using it. You're getting better feedback. They write things for it, tools, applications, and things like this for it. And just you get people with a different view looking at the language and coming with comments and criticisms and suggestions, etc. for it.
Okay. And what are some of the success stories outside of Ericsson after, I mean, this was the 25th anniversary this year of Erlang being released as open source.
So our company, Bluetail, was a success. We were finally bought up by Nortel Networks, around a few steps along that, which was fine.
2 steps or 1 step back?
2 steps. First bought up by a company in the west coast of the US, who were then bought up by Nortel Networks, so we will end up working there. But then the IT boom ended and things became very different.
We were expecting Nortel to be acquired by Ericsson, so we'd have the full circle. There, but
Ericsson was buying stuff there as well too. There was a lot of changes going on. About that time, I actually left the Erlang community for a while. So again, until I came back and started working for Erlang Solutions later. So apart from, I don't know that many. I think you probably have much better contact for what was going on in those first couple of years, right?
Well, I mean, I think Nortel was shipping a lot of products, which were based on Erlang was spreading like wildfire It started around 2005, 2006, but Nortel, many of the telcos, it was a way for them to actually save money more than So they'd invest and save by investing, both for building your infrastructure, but also saving in terms of increased productivity.
Well, still is a very good language for building that type of system, right? And also, I think about then it also started spreading to other types of applications, not just telecom.
That's correct. I remember working my first banking system in 2004, and that was a real experience. Databases, NoSQL databases. At one point, at the height of NoSQL, I think 7 of the 10 top key value stores were all implemented in Erlang.
All that type of stuff really surprised me because, as I mentioned, we were very focused on developing a language and a system for looking at telecom applications, and hearing was being used for other things came as a surprise. I mean, the first time I heard that Erlang was used for a web server, I thought, why would anyone want to write a web server in Erlang? But when you think about it, it's quite natural because the type of problems you run into, the type of things you want to solve are very close to each other actually. So
I was going to mention web servers, and the fact is, we had probably the fastest and most powerful web servers. If you look at the benchmarks from 2002, 2003. But no one ever thought of packaging it as a standalone web server and shipping it as you'd ship Apache or many of the other web servers.
Well, we were very bad at selling it, sort of selling the product, right? We weren't very good at doing that. Others came along later that could do that much better.
Nismnesia was another, it was the first distributed database, which I came across in 1995, and it was, in fact, if you didn't use it for transactions, which we weren't aware of the cap theorem back then, but if you didn't use it for transactions across distributed systems, it was incredibly powerful. It was a distributed key value store, which didn't necessarily provide strong consistency of your data, but that was taken care of in your business logic. So it was an amazing cache.
Again, that's getting back to things we hadn't expected that used the type of properties that Erlang and the systems around it had that provided for it, and it's been spread to a lot of different things as well.
And again, the question is, how did one pitch to manager? How did one get the budget to go in and write your own database? Today, I doubt many companies would get that budget. It's their database you can just go out and use. But back then, it must have been huge.
From what I can recall, it was needed in some of the products, the internal products for it. They needed a database for doing these type of things, and they needed the distributed fault-tolerant database. So they were paying in that sense, became quite natural just to implement it in Erlang. Right?
There was nothing on the market back then.
No,
there was absolutely nothing when it came to comes distributed. I remember demoing it in the 90s, and people were just like, you'd write in one node, and the data would appear in another node, and people thought it was black magic. they loved it.
It's not black magic, it was just how it...
Yeah, I know, but they'd never seen anything like that. And it was just like, oh, wow, this is super cool.
Yeah, I think, well, from my point of view, the fun part is that it was built on the basic concepts inside Erlang.
Yeah.
That they weren't developed for doing Amnesia, but Amnesia could use them in a good way.
Yeah, but then the only API you could have at the time was through an Erlang API.
Yeah.
They did add Corba, but it's not something we really speak about these days. Yeah.
It was, in that sense, it was restricted, yes, to Erlang systems.
When did you realize? So Erlang is a programming language. I think the first. It was running on a virtual machine called the Beam. Initially, the Jam, which then became the Beam. The first programming language I think I became aware of, which wasn't Erlang on the Beam, was Raya, which was a Ruby-inspired Erlang, basically, which goes to show it wasn't a bad idea. If we look at look at what happened 10 years later, but we then came across Efene, which was a C-inspired language written by Mariano Guerra. You wrote more or less at the same time, so 2008, 2009, Lisp-flavored Erlang. I think that was the first.
That was me, because as a functional programmer, I started off with Lisp, and I've always been fascinated by Lisp.
So these are just 3 or 4 languages we mentioned in 2008, 2009. And when did you realize that this programming language you built at the lab had become an ecosystem of languages, together with tooling, virtual machines, frameworks, and different languages, all suited, to solve different problems?
I think that was a bit later when Elixir started appearing on it. That was a major change in that direction, going towards an ecosystem, right? Because that came, I think, in 2011, 2012. It was officially for it, and that became a very significant language used on the ecosystem. And it was originally came from a lot of influence from the Ruby on Rails environment for building web servers. And they expected things like tools and development systems and things like this to exist, right?
Well, and they had a completely different development approach than what you would have in kind of server-side backend systems. Which was top-down. We were used to bottom-up because you'd like to solve the hard problems first, because if you fail solving the hard problems, you'd fail in the project. So there's no point in gluing everything together. They were doing UI, UX. You needed a top-down approach because you needed to see what you were doing.
Definitely. They had different targets, different requirements as well, too. I mean, a lot of the systems we've been developing, we expected them to run for years. And if it took 2 months to develop the system, that really wasn't much. That wasn't very bad at all. That was quite good, actually. But if you're coming from the other side, you might want to get your system up in a week, right? And then you just have to have different set of tools which you can use to build these type of things for. And that's what one of the things that came with Elixir was these tools, was these build systems and things like this, which came in from a very early time and helped the language spread a lot, which is still doing.
What I really like about Elixir is also the frameworks which come with it, where you're productive just by knowing a subset of Elixir. Have you looked at any of these frameworks?
A bit.
And I'm not just talking Elixir. I mean, we've got frameworks in the Erlang world as well, and I'm sure, whatever new languages come along.
Well, I'm expecting, I think, there are a number of new languages coming along on top of the Erlang ecosystem, and I would be very surprised if they didn't come with frameworks. Because the language themselves might be very interesting, like the statically typed languages coming. But without the framework, I think they wouldn't be that interesting for people to actually use, right? Not seriously.
I mean, one of the questions I always ask programming language inventors is, what problem are you trying to solve? And I love José Valin's answer to that question. For those of you who don't know, José Valin, is the creator of Elixir, and he said, I wanted to bring the power of Erlang to a wide range of communities, starting with the web, but not stopping at the web. So, he's created Phoenix, the Phoenix framework, which is kind of the new Ruby on Rails. So there's a huge influx of UI, UX, Ruby and web developers coming into the community. In parallel, I think what happened is they took the work we were doing on Erlang Embedded and started building on it. And I think we were out too early with embedded frameworks. I don't think the world was ready when we were working with it.
No.
And we had a lot of users, mainly hobbyists, but with Nerves, it's finally making it out into production and into the real world, and that's absolutely fantastic and brilliant.
But he had the same idea. He was looking at a specific type of problem.
Yeah.
Right? How can we use the Erlang as the base for this? Well, he built a new language on top with specific properties. You have the tools, you have the applications and packages that were there, so people just use them very quickly and get going. Again, just very, very problem-oriented in that sense for it. And as you mentioned, the Phoenix for building web servers. And Ecto for doing the database backend for them. They came very early on in the system.
And I'm loving all of the components which are slowly coming out. It will take a while, but which around machine learning.
Yeah.
And bit by bit, brick by brick.
Yeah.
If they're able to reduce the barrier to entry and accessibility of machine learning in the same way they did it for web development. Again, that's going to be another huge influx of
I've looked a little bit. I was starting to look a little bit at those systems, and they seem quite interesting, quite straightforward in many ways as well to using them. Then we'll see how it goes.
But where do you think the future will take us?
I don't know. I think one thing definitely is going to happen. There are going to become more languages in the ecosystem.
Well, there's something like 35, 36.
Yeah, there's a lot there, but many aren't used, of course. But I think it's just the fact that Elixir came in and is being extensively used shows that there's a lot there we can build on, or that can be built on. And so what's coming now, for example, are statically typed languages, because the original Erlang language and Elixir on top are dynamically typed, and people require static typing, or very much would like it. So there are coming a number of statically typed languages built on top of the Erlang ecosystem.
I think the first statically typed language which kind of came on my radar was Alpaca.
Yeah, that was one.
But then Fez. And I think the one which is gaining most traction of them all is Gleam.
Yeah. It's become a big requirement for systems, for what people want for building their systems.
It's security, as I see it. Yeah. With the Beam, Erlang and Elixir and other languages making its way to devices, some of these devices have to be secure.
Yeah.
And we're seeing right now Crichton, which is a SCL4 kind of proven operating system. The kernel of the operating system has been proven to be safe and secure.
Yeah.
But as soon as you've got a dynamically typed, and the Beam is a first-class citizen.
Yeah.
Security is provided by using concepts of kind of isolation and immutability. But as soon as you've got a dynamically typed language, you're opening yourself up for a whole new can of worms.
Yeah, that I know. Unfortunately, depending how you want to see it, one of the requirements we had when we were developing initially developing the language in the first 10 years it was in use, required or could not handle static typing, because we wanted to be able to upgrade the system while it was running new code and things like that, and do that properly. You would require dynamic typing.
Yeah, because you don't link modules together,
but now that's changed quite a lot, and the static typing requirements are quite strong now. And I think it will come. There's no doubt about that. I think it will come. The languages, the latest one I know about is Gleam, which is being seriously developed, and I think that will start being used. Or there might come something else. I don't know for it, but I think that is something that is being attacked today. Yeah. And when that comes, that will definitely open up the Erlang ecosystem to more uses for it. Because I think once the static typing comes in, it'll probably migrate it to other systems as well, do things for it. So it's a big change, but I think the system is dynamic and versatile enough to be able to handle things like this. It's not static in that sense, right?
So to the next 25 years then.
To the next 25 years, yes. Hopefully we'll see what happens with it, how it goes, and it is continually growing. The number of companies using it, and the number of systems that have written in Erlang languages in the Erlang ecosystem, which people being extensively used, which people just don't realize it is Erlang at the bottom.
You know, Joe Armstrong in '96 told me, "Oh, Erlang won't be around forever. You know, something new, something better will come along." And I said, "Okay." You know, and never would have believed that, you know, over 25 years on, you know, I'd still be working with it.
Well, I think it was dynamic. It was simple enough in the right way. So you could use it to be very versatile for building things on top. So it made it very adaptable.
Yeah.
So as we've talked, a lot of new ideas have come, but they've been able to be implemented on top of the Erlang ecosystem and at the same time use the benefits of the Erlang ecosystem and add new features to it, which have been required.
Just to wrap up, what would you say to those claiming, oh, it's a 25-year-old technology?
It was started 25 years ago, but it has continually evolved. Even the Erlang language, which actually looks like very much it did before, that new things come in, and we've talked about new languages, new features, the virtual machine, the beam, that is continually being evolved. That is, every new version that comes along is much better than the previous versions. Not saying the old versions were bad, but just new features come in. And again, they're backward compatible as well, which is a requirement we've also had and things like this. And they'll just keep going.
So yeah, so basically all of the changes are happening under the hood.
Yeah.
And you know, I think one of the major changes in the recent year is the JIT compiler, just-in-time compiler, for example.
That was a big change, yes.
Which was, just that, you know, when WhatsApp went in and upgraded their servers, they were able to reduce the server needs by 30%. Just thanks to this, optimization.
Yeah.
And those are the types of things which are happening under the hood. So languages existing and new languages on top of it, even if they're not evolving, can take advantage of it.
Yeah. Oh, yes, it is. So no way is the system static at any level, really, for it. And so work's going on everywhere for it. New packages are coming in, new languages, new implementations in the base and things like this for it. And it just does a lot of things that you want for you, without having to worry about it. Like concurrency and parallelism, and it's just there, right? And I don't have to think about it. I know the system does it, and I'm happy with that. It just works. And it works. That's the most important thing. It just works, right?
Brilliant. Well, we'll have to meet up in 10 years' time and see if our predictions are correct and see what happens.
Yeah. It won't. I think it'll still be there, but it won't be the same.
Oh, no, absolutely.
No, that's nothing.
Everything changes.
Everything changes.
One needs to adapt to change.
It'll just get better. Just get more and get better, I think. Most definitely.
Right.
Okay.
Thank you, Robert.
Okay. Thank you, Francesco.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.